This is the video lesson for Introduction to Electrostatics. The learning target for this lesson is, I am learning to describe how objects become charged by the motion of electrons, and how like charges repel and opposite charges attract.
The success criteria for this lesson are, I can describe how objects become charged due to the motion of electrons between objects. I can describe how the like charges repel each other. And I can describe how opposite charges attract each other. So what is electric charge? Well, atoms have both protons and electrons. Protons are positively charged, electrons are negatively charged. Usually, an object is neutral, meaning it has no net charge. So in other words, it has an even number of protons and electrons. So when an object has more charged particles, it has an overall charge. So more charged particles of one type or another means that it's going to have an overall charge. So if the object has more protons, it's going to have a positive charge. And if the object has more electrons, then it's going to have a negative charge overall. So this brings up the question, how do objects become charged? So in order to become charged, an object has to gain or lose electrons. So only the electrons on an object moves. The protons never move. So all objects are made of atoms. All objects are made up of all sorts of different things. All those things that constitute an object are made up ultimately of atoms, and those atoms have protons and electrons. The electrons float around on the outside of the atom, and those electrons move around. And the movement of those electrons is what creates a charge on an object. So only the electrons move. Protons never move. Protons are in the center of an atom and they can't move around, but electrons can. So there are lots of different things that cause electrons to move, which is what creates charge on objects. So here's a couple of examples, a few examples of things that cause electrons to move around from one object to another. So when you walk around on carpet, especially if you're barefoot or you have socks on, that can create a charge, a static charge on a person. If you've ever walked around on a thick shag carpet and then you touch a doorknob and you get a little shock, that is evidence that you have accumulated a charge on your body. Rubbing a balloon in your hair or on a shirt or something like that, again, that can create a static charge. You are transferring electrons from one thing to the balloon. So from your shirt or from your hair onto the balloon, that creates excess charge on the balloon. And another example is a clothes dryer. So you will often run into a situation where you will have static cling, they call it, where your socks stick together in the dryer. So that is another example of electrons moving from one object to another. So your socks are tumbling around inside the dryer and they get stuck together. That is another example of electrons moving and creating a static charge.
So how strong is an electric charge? So electric charge is measured in coulombs. That's the unit we use, coulombs. So one coulomb is equal to the charge of 6.25 times 10 to the 18 electrons or protons. So that is a very large number. So 6.25, so that's 625 with 16 zeros after it. So that's a very, very large number. So the charge of one electron or proton is 1.6 times 10 to the minus 19 C, or 1.6 times 10 to the minus 19 coulombs. So an electron or a proton has a very small charge. An individual electron has a very, very tiny charge. So that is 1/16 or 1/6 with 18 zeros in front of it. So a very, very tiny number. So we usually only use a tiny portion of a coulomb because a coulomb is such a large number. It has such a large charge. So we either use a microcoulomb. So 1 microcoulomb is 1 times 10 to the minus 6 coulombs. So that's what we call a microcoulomb. Or a nanocoulomb. That's 1 NC. That's 1 times 10 to the minus 9 coulombs. We call that a nanocoulomb. So we'll use these when we do calculations with coulombs, when we're trying to calculate different things like charge and the force on an object due to the charges on them. All right, so like charges repel each other. So here we have a diagram of 2 charges, and these are the force lines. These are the lines of charge that come off the charged particle. So these we can imagine are atoms that have lost electrons, and they're in close proximity to each other, so they have positive charge. So we think of these as ions, or these could be 2 objects that just have more protons than electrons. And you can see that as they come close to each other, they're pushing off each other. These lines of charge are repelling each other. They're bending away from each other. So they are repelling each other. And here's another example of like charges repelling each other. So we can think of these 2 objects as being balloons. So we have 1 balloon here and 1 balloon here, and these are both negatively charged. So both of these balloons have negative charges on them. And if the balloons were hanging from the ceiling by strings here, so they're hanging by the ceiling from the ceiling by strings, and as the balloons come closer to each other, the negative charges, because they're like, force the balloons away from each other. So if the gravity is pulling the 2 balloons down, and you would imagine that they would swing together, the like charges force them away from each other. And similarly, in this second picture here, we have the same setup, except these 2 balloons are positively charged. So they have a net positive charge on both the balloons. And as they swing down towards each other, the positive charge is going to force the balloons away from each other. So these like charges repel each other. All right, and opposite charges attract each other, similarly to how like charges repel. So here we have two objects. Again, we can think of them as 2 ions, 2 atoms. One is positively charged, one is negatively charged. And here you can see the field lines. So the force lines are moving from the positively charged object to the negatively charged object. So they move in this direction. So they're coming out of the positively charged object and moving towards the negatively charged object. And here we have another example with balloons. So we have the positively charged balloon and we have the negatively charged balloon. And these 2 objects, these 2 balloons, because they're opposite charges, will attract each other. So even if you tried to hold them apart from each other, they're still going to try and attract each other. They're still going to be attracted to each other. So even if you tried to hold them apart, they would still want to stick together, because opposite charges attract each other. The positive and the negative are going to want to stick together. Okay, everybody, keep asking questions. It's how you learn new things.